Well, good evening, everybody. Back again, back home. And this was the view outside to the west just a few minutes ago. It's getting dark. Winter is quickly closing in on us. And we're losing about 2 minutes of daylight, 2 minutes of sunset every day. And also losing 2 minutes of daylight on the sunrise. So altogether about 4 minutes there every day. And you could see those little streaks. I don't know if you saw that on that one shot there. A couple of white little pillars reaching up. And that's from these little towers you see here out around the Waco area up to southwest of Fort Worth. Casting a little bit of a shadow there as the sun sets up in the higher levels of the troposphere. Very quickly, I wanted to point out, if you notice any issues with the audio, just let me know. You know, we're continuing to enhance and upgrade this webcast and get it smoothed out and running, so just let me know. You can see some big storms out to the west, out there in West Texas. See that right here? From about Fort Stockton up to Big Spring and then back towards around Clovis, New Mexico. Big area of pretty good storms, and you can see one feature these anvils streaming to the northeast, and they've got some decent length. So that's quite a difference from the mush you usually get down to the south, like on these things. These cells here they've got anvils stretching out about 125 miles or so. And certainly we've got some severe weather taking place there. This is the radar composite from SPC with the surface chart. I'll get into more detail on the surface data, but this is just kind of a quick overview, and you can see one big storm right there west of Odessa. And I've got that pulled up on GR level 2. And we've got a tornado warning on that. Let's zoom in on that. So here's the Fort Worth, no, that's not Fort Worth. That's the Midland International Airport radar site, and Midland is over here, and Odessa is right there. So the storm is kind of coming for the western suburbs of Odessa. And this has been moving very gradually to the east-southeast. Now remember, when we saw those winds aloft, let me switch over to that real quick. Where did I have that chart? Okay, yeah, it was right here. You notice we had a northeast component to those anvils. But on the radar, we've got a southeast movement. So this is showing us the deviant motion we have on the storm. It's moving well to the right of the upper level winds. And that's a very good indicator that we have a severe cell. It looks a lot different from this cell further up to the northeast. And we've been talking about radar indications of severe cells using non-velocity products. And here you can see the stronger reflectivities piled up in the south part of the storm. The bulk of the storm is way up here, and the center of it is right there. So we've got these stronger reflectivities way down in the south part, and we're getting a strong reflectivity gradient down there. And of course we also have the telltale signature of a supercell, the enhanced V with that little bit of shadowing right up here, and most of all the hook echo. And you can see boundaries. That's a very prominent thing on this radar image. There's a large scale boundary. This is what I would call probably mesoscale. So this is on the scale of many hours and hundreds of miles. And that's kind of the broad scale surface flow across West Texas. And down south of there, we've got these southeasterly winds there. So this is a big convergence zone. And actually, that's acting to enhance the storm, because if you think aloft, okay, here's the boundary. Now think of these inflow winds coming from the southeast. They're actually riding over the top of this air mass like that. When you get a couple hundred feet off the surface, maybe 1,000 feet, 1,500 feet off the surface, but down where the ground is, we've got this flow from the northeast. So that's given us some tremendous low-level shear. So if we took a wind vane from the surface, initially we would see it coming from the northeast, and then within the space of a couple of hundred feet vertically, it shifts around to the south. And that's one of those things that enhances curvature in the photographs, and that gives us an enhanced storm relative helicity. So that's one thing you can look at even without cracking open a photograph. Now also on this image we can see a small scale storm scale boundary. Let me run this back one frame because it looked a little bit better right here. And there's that boundary right there. So this is kind of the deeper, this represents the deeper low-level inflow. It's making a mark there on the radar image. And if I go over to spectrum width, sometimes we can see it, sometimes we can't. I can definitely see the mesoscale boundary south of Odessa, but the storm scale boundary doesn't show up so much, and that's probably because it's kind of shallow and elevated, slightly elevated. And I'm always curious about storm tops, so let me just check that out real quick. 19.5 is as high as we can go. See, I've got 19.5 selected, and the radar is going up past that, or the storm is going up past that. So the tops are in excess of about 43,000 feet. So the top part of the storm is within the cone of silence of that radar, and if we really wanted to get tops on that, we'd have to go to another radar like San Angelo and look at the lower tilts on that. Okay, so that's our great storm of the day. We're finally getting some action, and this is probably a left mover up here. And I'm saying it's a left mover because the stronger reflectivities seem to be on the north part of the storm. So this suggests that we've probably got kind of a supercell configuration, kind of like that. It's kind of mirrored. And there you go. You can see the northward movement slightly to the left of the upper level winds. Now usually these left movers are kind of elevated and they don't have much access to anticyclonic storm relative helicity, so anticyclonic tornadoes are kind of rare, but they do happen occasionally. Okay, then further out we've got some more good storms. It looks like a very good chase day. This one is out north of the caves. What are those caves? Carlsbad Caverns, and west of Hobbs. Definitely a good storm there. And then there's some other ones that are way out west of the radar site. These are over the Davis Mountains out near Guadalupe Peak and all the way down to around Marfa. So those are definitely capable of producing some severe weather. So finally we got some good stuff to look at, and when we get more of these storms coming up for a forecast day, that's when I'm going to start promoting the channel and running some ads, and we should see the chat room get really busy. I'm expecting probably we may get at least 20, 30, 40, maybe even more people when that happens, but I'm going to wait and kind of bide my time, and maybe in the next couple of weeks as we get into early fall, we'll probably do that. Okay, switching back to our graphics, why are we having those supercells? Well, one answer is on the surface chart. We've got a very distinct boundary. I'm going to have to move this down so you can see it better. This is West Texas. Here's Midland. Then Abilene is right there, and Lubbock is up here. And from yesterday, we kicked down this outflow boundary that we talked about, and that's kind of stationary in this area. It's been kind of sitting there, and the storms have initiated along that boundary. And they're being fed by a little bit of moisture, not very rich. We've only got 60 right there, but there could be some stronger values in between. That's definitely possible, and we got this 71 off the bottom of the chart down near Sanderson. So this tells me we could have some higher moisture in here, and you can definitely use the high resolution rapid refresh model to kind of gauge that, because that model can sort of interpolate between the stations to a certain extent. When you've got large gaps like that, you can kind of fill that in with some moisture data from those models. That'll be a good thing to show you for a upcoming weathercast. So we got the boundary there, we've got strong heating, we've got dew points kind of creeping up to 60, and definitely some good shear there. So of course we want to look at the soundings. This is the Midland sounding right where that storm is occurring. This is for 12Z. And the big thing that I see on that is deep moisture right there. Normally your moisture kind of trails off. You'll see something like this, like what I'm drawing. That tends to be the norm, but we have kind of a enhanced moisture profile, and that's going all the way up to about, that's probably about 4,000 feet thick. So if we construct our lifted parcel, we're going to come up with, let's see, what did they get up to, 90, 91? That's going to be about right here. Then we lift our parcel. And those of you who have looked at soundings a little bit and kind of try to experiment a little bit with that and get up to speed, you probably know that when these lines sit well to the left of the environmental line, that's a good indicator of very strong instability And Cape is actually the geometric area that we have in between. So this whole area in between is Cape, and this to me looks like at least 2,000 to 3,000 capes. And the other big ingredient we have here is capping. When we looked at soundings a few days ago, we weren't seeing any capping. But now we've got this layer right here, 780 millibars, which is about 8,000 feet up. We've got about 68, 67 degrees Fahrenheit there. It's funny to think you can take a hot air balloon and go way up there and things are still kind of balmy. So that's reflecting the cap, which is overlying this area. So that allowed the storms to kind of brew for a long time this afternoon, and finally they popped, and what do we get from that? We got our supercell action. And with that, of course, we've got some watches across West Texas and northeast New Mexico. Those are the severe thunderstorm watch areas. And that's the big action of the day across the country, unless you want to count this little severe thunderstorm watch in Oklahoma, and looks like a couple of, I don't know what that is, something in eastern Lake Ontario, and then red flag warnings across Cheyenne, and that's about it. So let's look southeastward to our hurricane action. We've got Julia in the process of recurving to the north, and Carl is doing the same thing. And we're looking at this next wave coming off the coast of Senegal in Africa, just south of the Cape Verde Islands. This is looking a little bit too far north, but we'll kind of keep an eye on that. Things are looking pretty quiet in the tropics so far. Let's check out their 5-day movement. Yeah, see, they're recurving that thing. So I think the hurricane chasers out there that are gearing up for this year, I think they're probably a little bit disappointed. But I guess on the other hand, we don't have, a big storm crashing into the coastal areas. That's not all that great either. So whatever happens, happens. But there's the big picture from the polar orbiters, and you can see them passing over the tropics, and they build up these swaths. An hour and a half later, I'm actually going the wrong way. They start out here, next swath comes down, next swath like that. And so we build up this picture of conditions across the Atlantic. And things are actually pretty quiet. Maybe a weak easterly wave here just south of Cuba. Looks like another one around the Lesser Antilles. Then we pick up Carl here out in the middle of the Atlantic. And then there's that next wave, but that's looking to be pretty far north. But this has some potential right here. This is around, I guess, the Ivory Coast. So we'll watch this over the upcoming week. And so that leads us into the forecast. And since it's September, I'm going to use the precipitable water and pressure. And just to start us out, well, I'm going to have to recenter the window. Let me put that, there we go. And let's see, what do we have? We have low pressure in northern Alberta. So big old low there, part of this large area of low pressure in Alaska and northwestern Canada. And when that happens, we don't really see any polar outbreaks coming down from the northwest. That tends to mix the air a little bit and brings a lot of moderated air from the northern Pacific inland. And so we're going to have to wait a few weeks before we generate, not a few weeks, at least several days before we generate more polar air. However, we also have a lee side trough. See that right there? When you get strong westerlies across the Rockies or any north-south mountain, you'll get a lee side trough. So there it is. And it extends all the way down to Colorado. Another low going through the Lake Superior area. Looks like kind of a weak front going through the Midwest, through Illinois, right here. And then down towards Texas, you can see a very weak boundary, and that's part of that boundary that's affecting the Midland area. The bulk of the stronger moisture is a little bit further to the east in Mississippi and Alabama. So there it is right there. And let's see, the Pacific High looks to be receded a little bit, not making much headway inland. And also the Bermuda High looks to be a little bit on the weak side also. So not a very deep fetch of southeasterly flow coming into the United States. So moving forward to tomorrow night, looks like that low pressure system in Canada moves westward, and we've got a front pushing out too. Maybe a weak surge of cool air coming out of the Northwest Territories. And that's the main action, really. A little bit of moisture just off the Texas coast there, but looks to be pretty dull. Sometimes we might have, in a situation where we have these storms out in West Texas in very stagnant patterns, we can often expect the same thing on the next day. And that might be the case. You can see that nose of moisture coming into West Texas tomorrow. So there may be some chase opportunities coming up for the Midland area yet again. So going forward, the low pressure system in Canada continues moving eastward. And we get this other low developing in the South Dakota area. That doesn't do very much. But now towards Thursday, we start getting high pressure developing in Canada right there. So see that big old high? Now we've got polar air starting to develop across Canada. And that doesn't go south very much. It's mostly blocked by this low that's continuing to sit there in Nebraska. So highs up here, things stay kind of stagnant. The main frontal boundary is going to be draped east-west through the northern plains, kind of like that. This is next weekend. And down in Texas, very deep tropical flow coming on shore here. So it looks like precipitation chances should continue through the week here in Texas. And then finally, next week, well, not next week, but after the 26th, now we start to get a kick of high pressure coming into the central U.S. Large high, looks like mostly Pacific air coming in. So this is going to be about 8 or 9 days from now. And we get a huge front coming into the Texas and Georgia, Alabama, Florida. And so that will probably mark the start of fall. So what kind of temperatures are we going to see with that? I haven't really shown this chart, but the GFS does show temperature data. So let's run that up to next Monday, Monday the 26th. Okay, so here you can see the front coming down. The shading, see this red and yellow shading? That's moisture. What we're looking for is temperature, and that's going to be these red lines like that. So let's see, this is going to be Wednesday morning. Oh man, this is the 18Z model, so the intervals are only at midnight and noon. So that's not great, but I'll go ahead and stop it at midnight on Tuesday night. And here we've got a 10 Celsius isotherm. Let me paint that out. So this is going to be the 50 line, all the way down to Georgia, and all the way over to around Harrisburg, to Syracuse, and down to Asheville. So definitely looks like a shot of cooler air coming in, and then the 59 line or 15C line goes all the way down to, looks like Jackson, Mississippi, into East Texas, and into eastern Oklahoma. And sometimes the model tends to smooth these things over, so it could very well be even cooler. You may see widespread 50s across the south. We'll see how that comes together. We're still 240 hours out, but that'll be something to look forward to and get rid of this hot air. And I was getting eaten up by mosquitoes filming that dusk scene that you saw in the opener. So let me check out what's going on in the chat feed. Hopefully I didn't bore you. This is running about 20 minutes here, but that's the forecast picture there. Let's see, a lot of people hoping for rain, which is good. There's a viewer from Argentina. That's great. I appreciate that. Digital atmosphere user. Okay, well, good to see you guys on here. I'm going to leave with a closing video here. This will give you something interesting to look at, and I will see you tomorrow night. Thanks for watching. What's this? Well, that's got to be good news for the live cast. 6 megabits per second. Well, that's not great, but I'll take what I can get. I thought we were on 6 already, so I don't know. Well, do you all remember this thing from last week? Figure we might as well take a look at that, see if it's any good. Let's see what's in it. Milk chocolate, potato chips, bacon bits. Well, we shall see. Yeah, I might as well unwrap the whole thing. So we got ourselves a potato chip and bacon bar. So let's see what that tastes like. Very smooth chocolate. It's almost European. Got a mosquito here. Yeah, you can't even really taste that it's a potato chip. It's just kind of crunchy, like not Rice Krispie bars, but crackle. Tastes a lot like that. And I don't really taste the bacon so much, to tell you the truth. Maybe a slight hint of it. Yeah, I gotta say that's pretty good.